welcome Maria to the stage.
Good evening. Just waiting for my slides to come through. And it's story time. That's why I grabbed the chair, just to get you in the vibe. Don't go to sleep. It's not that kind of time yet. So I think that you're all familiar with Batman. And I think that you're also familiar with this phrase that says, "Why do we fall, Bruce?" So how did that phrase happen? As you know the story, young Bruce Wayne was playing with his friend Rachel in the mansion of Dr. Wayne. They were looking for a relic. And then at some point, young Bruce fell in the well of the mansion. The well was full of bats, which was Bruce's biggest fear. And not only he fractured his arm, but his heart started racing because he was terrified. But thankfully, his friend Rachel was there, and she ran and she grabbed Butler Alfred and his dad, Dr. Wayne. They grabbed young Bruce, and while young Bruce was in the hands of his father, that's when his father asked him that question. But young Bruce was too innocent to know what that question was. But we will find the answer later. And we will see how that is going to be related to some science of my project. How does a fall can relate to science? So now I'm going to transfer you over to some science from the fairy tale. So this is, in a very nutshell way, my project. Where you see the question mark is where the magic happens. So my project is called singlet fission, which is what gives this outcome of the two triplet states. And fission basically means a split. So you have a singlet state, which is an excited state, which is S1. Okay, and then once that is split, it's going to give me the two triplet states. It's literally the opposite of fusion, okay? And where you see your thunder here, this is light, this is the excitation, this is the laser that I use in my lab, okay? And you do need to have some prerequisites. You cannot do this to every molecule. So these molecules are called chromophores because they can allow this phenomenon to happen, and they can change their color when they absorb the excitation. And then they do need to have a nice neighbor that is like them, okay? And then after they get excited, so from ground, S0 state, they get excited, and then the singlet state, via magic, singlet fission, is going to give me these two triplet states. So, as I said, excitation is what happens when I have my samples and I put laser on them. Or just like you excite someone, right? You go there with a lot of energy and excitement and you just excite them. And then emission is what I detect, which comes in the form of funky light as fluorescence. So what I'm detect, as you can see there, PL for photoluminescence, is once this excitation goes down. So it's not always a bad thing, right? The downfall, because I need that in my science to detect my data. And because it's in a dark space, in order to see that, it's a great example that you have in front of you these funky bracelets. Because if you imagine that all of you, you're in a box, in a dark box, like this dark room, you could all be potential molecules that I'm detecting. And after I excite you with the correct laser, you're going to give me a different color, because you're all different samples. So I want you to break that, just to activate it, okay? And then maybe you need to give it some shake to just get the chemical around. Make sure it's bright, okay? And then pop it on your wrist, okay? And then you're signing, like you could all be one of the excited samples. So this is the box. This is my experimental setup. This is all of this room, right? We're in a dark space. You get excited with laser, and then you give me photoluminescence. So that's why now you're bright. You've been excited, and you're giving me back signal. And because this signal is very sensitive, and this detector here, this detector here is gonna measure your photoluminescence. You need to be in a dark space. That's why it's great that we're all in this dark room. And you can picture that as you're all the potential samples. It looks cool, right? This dichroic plate is to allow only the photoluminescence, like what you have right now. Let's say that you're excited and you have photoluminescence that you're giving me back. I want to detect that photoluminescence, and I don't want to detect the laser back, because that sensitive thing over here is gonna burn if the laser goes to that. So I only want the photoluminescence that comes from you, the sample that I'm using to come back. So then this dichroic plate is protecting that. So this is the idea. You get the idea now, right? You've been excited. If that was you, you get excited with laser, right? And then after you've been excited, I want to detect what you give me back, and you give me back some great signal, which is great. That's what I want to detect. But I don't want to burn my sensitive detector, and that's what this cool guy is doing here. He's protecting that, because I just want the signal. It's that simple. And then after I get that, you just give me my data. And then I'm a happy scientist, basically. So, just to sum it up, it is about falling after all, which I started as, okay? Because as you see here, this is an energy axis, okay? You're in the ground state. You're, let's say, in your living room, you're bored, okay? And then, for example, your dog comes along and is full of energy and just makes you so happy and go crazy. And then that excitation makes you rise. And then the dog does something nasty, and then you get upset. Maybe you'll go down. But it's the same with the samples. You need to excite. I need to excite my samples in their ground state with some external magic, which is my laser. And then once they go up, they absorb this energy. And then once they go back down, either this way or either this way, that's when I get my signal back, which you guys are my signal. You are bright. So this bright thing is my signal. So I want to transition how that correlates so nicely with Batman in a way, and I love that. So I just want you to accompany me on that. There's not much information here. I just want you to accompany me on that. So I will ask you in a minute the same question that I started with, which was a really philosophical and really cool question. And all I want you to do, if you're happy to volunteer for that, happy, not happy, I just want you to speak with me, basically. I want you to answer this question that I will give you the answer to at the same time. And while you answer, just to show me how you rise, I want you to just raise your hand while you answer this question with me and out loud. It will be great. So I'll give you the answer, and I'll put the question through. So, why do we fall? So that we can learn to pick ourselves up. Thank you very much.